I need something to get you guys up and going and started right away. And that something is assignment 1, which is on the course website. And I'd like to talk a little bit about it, because now is the time to talk about it. You can ask me questions. You can ask me questions about the assignment at any time, usually at the beginning of class or at the end of class. But the reason I'm choosing now specifically to go over it is the next thing to discuss is some of the implementations that are available in the Java Collections framework and how to use them. And those are basically the key things that you use in this assignment. So that's what you pay attention. Now when we talk about these questions in the assignment, you may have no idea how to solve them, but while I'm talking about the classes that are available to you, you may think, oh, that sounds like one that could be useful for this question. In fact, you don't even have to know the classes yet. Many of the interfaces that we've just discussed, you'll think, that's the thing that I should be using for this question if you're fast. And so that's what I want you to think about. Each of these questions is basically about picking the right data structure to use to store things in and getting the output you want. Okay. So all of these have the same form. There's a little skeleton in there that does the stuff that it needs to do in order to read from a file or to read from system.input. It reads one line at a time. It converts that line into a string, and you process that. You process those lines one at a time as basically a sequence of strings. So when I talk about reverse order and so on, I mean reversed from the order that they appeared in the input file or that they appeared on standard input. So first question says that you should read the input one line at a time and then output the lines in reverse order, so that the last line in the input is the first line in the output, the second last line in the input is the second line in the output, all the way to the end, which is the last thing that you output is the first thing that was input. That's clear what that means? It doesn't mean take each line and write it backwards, so don't reverse the strings. It just means change the order that the lines occur in. Okay? Second question. Imagine that the lines are numbered. They're not, but as you read them, there's a first line you read and a second line you read and so on. So imagine they're numbered starting at 0. So you read the whole file, and then you output the lines that's, line 0, line 3, line 6, line 9, line 12, and so on. And then you output the lines line 1, line 4, line 7, and so on. And then you output the lines line 5, line 2, line 5, line 8, and so on. Okay, so the lines modulo 3, the line numbers come in 3 different classes. First thing you do is you output the ones that have no remainder when you divide them by 3. Next one's when the remainder is 1 when you divide by 3. And the next one's when the remainder is 2 when you divide by 3. Okay. Is that clear? So that's just reordering the lines in the file so that you get, the 0th line, the 3rd line, the 6th line appear first, and so on. All right? Next, read the input one line at a time, and again, the lines, imagine that the lines are numbered the same way they were before, and if line I is empty, meaning that when you read it, you just get an empty string, so a string of length 0, then you should output the line I minus 67. So go back up 67 lines and output that one. Otherwise, don't output anything. Okay. So the number of output lines that you get in your output is actually equal to the number of blank lines in the input. maybe a little bit less, because if you encounter a blank line in the first 67 lines, you don't do anything because there is no I minus 67. So the question is worded carefully. So the line number, line has to be empty, and the line number has to be bigger than or equal to 67. And there's a little warning here. Oh, it's not there, but I'll warn you anyway. Don't use more memory than you have to for this question. Okay. So there's no need, for example, to ever be storing more than 68 lines of the file at any given time. Okay. So again, now be thinking about what data structures you need for these things. Read the input one line at a time, and write each line to the output only if you've seen it before. So only if you've seen a line like this one before. So if this is the unique line you've never seen before, if you don't write it, otherwise you do write it. And, try not to, all of these things should be done as efficiently as possible, using the right data structure to make this thing as fast as possible and not to use any more memory than necessary. Okay. Next, read the input one line at a time. And now you're not actually going to output the lines that you see. What you're going to do is look at how many times you've seen this particular line before. It's just a string. You've seen it 0 or more times before. Output that number instead of the actual string that you see. Okay? So this gives the cumulative frequency of that line. How many times you've seen it so far. Okay, that's clear? Good. Again, question 6, read the input one line at a time. Like question 5, you're going to be somehow keeping track of the number of times you've seen each line. And then at the end of this process, I want you to output them all in decreasing order of frequency. So maybe you've seen some line 1,000 times. That's more than anything else. That should be the first one you print. Maybe there's another one that you've seen 800 times. That's the second most frequent. Print that. And so on down to the unique lines. And in case there's ties in frequencies, you resolve them using the normal sorted order on strings. So you just compare the strings that are the lines themselves. So that's just what they call lexicographic order. You can get that from using string compare. So this will give you the most frequent things in the input. Okay, here's one that requires a little bit of maybe an example to understand. So you read the entire input one line at a time. Now we're going to be comparing lines to say one is bigger than the other. For that, lines are just strings. We can compare them, ask if one is bigger than the other. And what I want you to do first is to output the largest line. So imagine the lines just contain, let's say, single-digit integers. Imagine they contained 4279. Oops. 4279086163. So what's the largest one there? 9. So the first thing you would output would be 9. Now 9 occurs somewhere in that sequence. It's right here. And there's a bunch of stuff that occurs after 9. Now you output the largest thing in that sequence. So 08163, the largest thing there is an 8. So that's the next thing that you output. 8 occurs somewhere in that sequence. You output the largest thing in the remainder of the sequence, which is 163. The largest thing is then 6, and then you output the largest thing in the remainder of the sequence. It's only one element left. It's 3. It's the largest thing. You output 3. So your output would be 9863 if that was what was on your lines. This takes a little bit of thinking to solve efficiently. All right. And the last one, question 8. You read the whole input one line at a time and output each line if it's not a prefix of some previous line. So prefix means that it starts some previous line, or it's actually, or it's equal to some previous line. So for example, help is a prefix of helpful, right? So help is the first part of the string helpful. So if I saw a line that started with helpful, and later I see a line that is just help, I won't output the line that says help. Okay. And there's a hint there that think about what happens if you compare help and helpful as strings. How do they fit together, and how would they fit together with other strings? Okay, good. So I see a few people thinking, meaning that it's not immediately obvious how to solve all of these questions. That's a good thing. Yeah. Yeah, so question 7, I can explain. So in question 7, there's this example, 427908163. 4, 2, 7, 9. The next one is what? 0. Next is 8. 8. 1. 6. 3. Okay. So here's the lines in my file in the order that I'm reading them. Okay? So the first line I read is a 4, then a 2, then a 7, then a 9, 0, 8, 1, 6, 3. So first thing I should output is the largest number in this set. So what is it? 9. So the first thing I will output is a 9. Next, I want to output the largest thing that comes after 9 in this sequence. So the largest thing in this set here. Okay. So what's that? 8. So I'll output this thing. Now after that, I want to output the largest thing that comes after 8 in this sequence. That's the 6. And after that, I want to output the largest thing that comes after the 6 in this sequence. That's the 3. Okay. So first start with the global maximum, and then the maximum that comes after the global maximum, and so on. Okay. So think of this as these are Olympic records, let's say, and some athlete comes along who is just way better than anybody will ever be, sets the record forever, no one is ever going to beat them, then you want to know, well, except for that guy, except for Michael Phelps, who's the best after him, because no one's ever going to beat his record, let's say. And do that repeatedly. Yeah?
In the assignment, we would assume that we're dealing with strings and not integers, right?
You're dealing with strings. So all comparisons, when I say larger than, greater than, you're just comparing strings.
Is it strings length or just compare?
Using the compare function for strings. So that's specified at the beginning of the assignment. Yeah?
Can we choose how a sorted set is sorted, or does it just by default put it in the increasing order?
Yeah, so sorted set and in general sort functions usually have a constructor or a version that allows you to specify what's called a comparator. And we'll maybe do an example of one of those today if we get to it. Comparator is a class that takes two objects and returns either a negative number, a 0, or a positive number, depending on whether the first one is smaller than the second one, whether they're equal, or whether the first one is bigger than the second one.
And if you use the compare to function after doing that, will it compare that value? Like, how do you compare with that new value?
Well, so usually you would say something like, I'm going to make a sorted set that contains strings, and this is the comparator you use for comparing strings inside this sorted set. Okay. If you want to use that comparator outside the sorted set, go ahead and use it to do that. But now everything you put in that sorted set is going to use the ordering defined by that comparator. And that comparator better make sense. Like it shouldn't have cycles. It shouldn't say A is bigger than B, which is bigger than C, which is bigger than A. That'll definitely break things. Yeah. Yes. Yeah. So including, so line is a prefix of another. So we say that S is a prefix of T. If you can write T by S plus something, including S plus the empty string. So yes, if the two things are equal, then they are prefixes of each other. That's the only case where S is a prefix of T and T is a prefix of S. Good. So some of you are thinking. Good. Any more questions about the assignment? How is what? The submission server will come online hopefully in the next week or so. Yeah.
Is there a finalized due date yet?
No, when would you like it to be? Careful. Do you really want to start this discussion right now? Yeah, no. No, it's not finalized yet. But it sort of depends how quickly we get through the next few classes. So just keep asking me dumb questions, slowing me down, and then that'll push the due date back. That's not a dumb question. I'm kidding. Yeah. Yeah.
How does it? How do you end the inputting streamline? How do you know when it's finished?
Well, if you give it a file, then it's the file. The thing runs off the end of the file. If you are doing this from standard input, I only know under Linux-like systems, you give a blank line and press Control-D. That signals the end of the input. Under PowerShell, somebody was in my office and we tried to play with it. I don't know what you do. Control-Z, Control something.
PowerShell?
Yeah, PowerShell is super popular now. Yeah. Or you can, there's now, Ubuntu on Windows, so just get that and use that instead. Yeah, good. Yep.
Would you look at the specific version of Java you want us to use?
I don't want you to use anything that is specific to Java 8. So any features up to Java 7 are fair game. Not anything beyond Java 8, but ultimately, I want you to use the version that this server is going to use to compile your stuff, which is some implementation of Java 7. You know. That's the real test. I mean, specifying a version number doesn't matter if it's not compiling on the server, then it's not satisfying the conditions of the assignment. Yep.
Is the server a Unix-based server, or is it a Windows server?
No, it's a Linux machine.
So it's probably running OpenJDK.
No, for some reason, somebody who was administering it, or actually who was TAing the course a few years ago, wanted to use the Oracle JDK. Don't know why. It doesn't matter. It's really, the level of detail is not going to affect whether your code is correct or fast enough. Yep.
Java, you set up to 7, so you have Java 6 on like a 9, whatever, that's fine.
So Java in general is backwards compatible. The only thing you may get is some deprecation warnings that say you're using something that you shouldn't be using anymore in Java 7. Those warnings will not affect your mark. But again, even that is kind of unlikely to happen for the kinds of assignments we're doing. Things that become deprecated are, well, sometimes things, data structure-y things, really old data structure-y things, but mostly it's networking things and GUI stuff that we're not dealing with at all in this course. Yep.
If you're recording, can you get access to it?
Yes, the first lecture is on the course webpage.
Someone said it's like 5 minutes.
It was. I've corrected that. Yeah. Yeah. Unfortunately, YouTube wants you to click a checkbox each time you upload a video to say that it's not private. So hopefully I won't forget that. If I do, just remind me and I'll fix it. Okay. Good. Hopefully within a week or so, I'll show you what it looks like when you submit an assignment and get 100% on the submission server. Okay. So I talked about all of these interfaces, starting with list, and that's fine to write them on the board, but some of you will still struggle a bit. Most of you probably haven't used Java generics yet. It looks kind of weird when you first see it, but it's pretty trivial. So I'll do a few simple examples. So remember, all I talked about were interfaces. This is just basically says what the data structure is supposed to do. It doesn't say how it does it. So when you want to create one of these data structures, you have to pick an implementation. So the first one we'll talk about is an implementation of the list interface. And it's called an ArrayList. Now remember, the list interface basically stores a sequence of things, and those things are indexed by number starting at 0. So it's not too surprising that, well, the first implementation you might think of for a list is an array, because an array stores a sequence of things, and an array has its elements indexed starting at 0. So it's like a perfect thing to implement this thing. And that's what an array list is. It basically stores your list in an array. When you say get I, it just goes to index I in this array and returns the value there. When you say set I to X, it just goes to position I in the array and sets the value X to there. When you say remove I. Remember, in a list, you specify the index that you want to remove, not the value of the element. It just goes to that position in the array. So let's say I is 5. It wipes out the value that's there. And then it takes the remaining elements in the array and moves them over by one position to fill in the gap. Because remember, in a list, when you remove an index, the subsequent indices come back to fill in. And in an array, it does exactly what you'd expect. It shifts everything following that element back one position. So that immediately has an implication on performance. So where is it really fast to remove things from? What's the fastest element to remove from an array list? Yeah? The last element, because then you don't have to shift anything back. What's the slowest element to remove from an array list? The first one, 0. The 0th one. Because then you have to take everything and move it back. Keep that in mind. Is this a small difference in performance? Depends on how big the array is. What if there's a billion elements in the array? Then removing from the end is a billion times faster than removing from the beginning. So, for example, on a modern computer, removing from the end might take something like 1 cycle. Maybe on a 1 gigahertz computer, that's 1 billionth of a second. Removing from the beginning, it might take something like a billion cycles. That's 1 second. So this translates into real times. And you'd say, oh, well, 1 second is still pretty fast, so no problem, right? Well, no. Okay, so let's see how to use one of these things. So first thing you have to do is make sure you've imported them. I was a little bit lazy here. I copied some imports. So I've imported ArrayList before I can use it, and I've imported list before I can use it. Okay. Here's a simple little bit of code that fills up an array of strings with a few things, a few items. Anybody recognize the names? I guess most of you probably do. And it just prints out what are the contents of that array. So have all of you seen this method of iterating over an array in Java? Okay. It's a nice thing that's sort of Java specific. You don't find it in you don't find it in C and older C++. So you just say, I have an array of strings for this S in that array. Do something for that thing. Okay. So let's do something silly, like take that array and put it into a list. So first thing we have to do is make a list. And we have to say what kind of list we're making. So all of these things, all of these container classes, these data structure classes, they hold objects. They hold objects of specific type. In this case, we know what kind of objects we want to hold. We want to hold strings. Okay. So I want a list of strings. I'll call it L for list. And so there I've declared L to be a list of strings. And remember, that's just an interface. I need to specify exactly which class I want to do this. So I create a new instance of ArrayList. So that'll create me a new list of strings. And all of the containers in the Java Collections framework, I can iterate over, just like I can iterate over arrays. So I can say, for every string S in L, print S, the same way I did for the array. And let's say, so what are the contents of L here? Nothing. So contents of A is all those strings that I put in A, but in L there's nothing because I haven't put anything in there yet. I've just created an empty list. So let's put those strings into L. So after I create L, put this closer to where I'm printing. So after I create L, I iterate through the strings in A, and what should I do with each string in A? Yeah. Yeah, so I want to put that string into L. What's the method for that? That's the add method. And I want to add S. Where do I want to add it? Yeah, at the end. So that would be at what position? So I take the size of L. So if L is indexed from 0 up through size minus 1, and I'm adding the new element, it's going to get the new index, which is size. So that's where it would go, right? I got it wrong. I got the order of these things wrong. You specify the index and then the string you want to add. Remember, add IX, not add XI. Okay, and now L contains exactly the same elements in A, but in the same order they occur in A. So first thing I'll let you in on is a little secret. Lists also have an add method that takes only one argument, which is the thing you want to add, and it assumes you want to add it to the end of the list. So a little bit shorter than that is just to say L.addS. That does the same thing. Okay. Now, what happens, for instance, if I do something a little bit differently, and instead of adding it to the end of the list, I add it at position 0? Do I get the same list? Yeah, so the list is the same in the sense that it contains all the same values, but they're not necessarily in the same order. Yeah? They'll be coming out in reverse order. So here you saw that they were coming in the same order. If I add them at position 0, they come out in reverse order. So Stuart was last in the array, it's first in the list. Howard was second last, second in the list. Is this a good way to solve that question on the assignment? What's that? Yeah, why is it not a good way to solve that question on the assignment? Yep. It's expensive, right? So I said get, set, and remove. I explained how they worked. Well, add, you can figure it out. If I add at position I, then that means the new thing I'm putting in is going to go at position I. Let's say I was 4. X is going to go at this position. And before I can do that, all of these things need to be displaced by one position to the n, meaning that if I add at position 0, everything in the array has to move over one position to make space for it. So That is one way to reverse things from the order in which you encounter them, is to add them to position 0 in an array list. But if you have a lot of things, that's going to be very slow. Do you believe me that that's going to be very slow? Do you need a demonstration? Okay. So let's do a demonstration. Let's make a list of integers. One thing to note here, I'm making a list and I want it to store integers. Notice that I'm using integer and not int. So all the collections in the Java Collections framework can only store objects. They can't store primitive types. That means they can't store int. They can't store float with a little f, double with a little d. They can only store the objects. But Java by now has cleaned things up, that there are classes for every primitive type. There's a class that is basically the same thing. For ints, it's the integer class. So I want to make a list of integers. Call it L2. This is a new array list of integers. And I'll do something like for I equals 0, I is less than, 10,000? I plus plus. Dot add I. So here I'm creating a list of 10,000 integers. Is this going to be fast or slow? How fast? 10,000. Second, 2 seconds, fraction of a second?
We should be able to tell, like, you print out, add it into your list, and then done, as if those were on the same line.
Okay. Pretty much undetectable, right? We couldn't tell without using some timer on some Java timer how fast that is. Basically says adding an integer list, done. The done is only printed after we're done adding, but we do that. We don't see it. Now what if I put them at position 0? Well, we've just said that that's going to be slow. How slow? Oh, this cable is dodgy. How slow? Like 2 seconds? Half a second? Very fast. So fast makes me wonder if I even compiled it. Let's try 100,000. This God. Oh no. No, it's not an HDMI cable. Back up. Okay, let's do that. Was noticeably slower. So watch it again. There's some time. Now how about 1,000,000? Now we see it. So if 100,000 was noticeably slow, let's say it took a second. How long is 1,000,000 going to take? 10 times more? It's going to actually be about 100 times more. Now, that wasn't fair because, so I've just stopped it, but that wasn't fair because we never saw how long it took to add 1,000,000 elements at the end, so let's just make sure that that's not also really slow. That's not slow at all, okay? So, this is the era of big data, everyone says. So if, 1,000,000 is not big in terms of big data, but it's noticeably a problem here. Yeah?
What's system.out.flush?
System.out.flush says everything that's getting ready to get printed, just print it out now. The reason is notice there's two different print things. There's a print and a print line. Generally, print lines come out right away. Prints don't always necessarily appear right away. If you flush, then you'll get to see them. Okay. Good. All right. What other things might you want to do with a list? So let's go back to our original list L. So is there anybody missing from our list of characters here? Is there anybody we could add to this list? No fans of the show? What's Sheldon's mom's name? What's the comic book guy's name? Stuart.
He's already in the list.
Stuart's already in the list. What's the Kripke? Kripke. Let's add Kripke. So we can add Kripke to the list and print it again. So I increased the font size on this so you guys could see it, but the cursor is still razor thin. So indeed, we can add Kripke to the end of the list. If we want to add them in any specific location, we can. So add them as the second element of the list. There he is. So add works as we expect it to. And which character would you like to see never on the show again? The most hated character on the show. Bernadette is terrible? That annoying voice? No. So what do I remove then? So remove what from the list if I want to remove Bernadette? Remove the index 3. I'm not going to check. I'm going to assume you're right. Stuart, Kripke, Howard, Amy, Leonard, Raj, Penny, Sheldon. Yeah, Bernadette is gone from the show. Good. Nothing too much more to say about that. You now understand all the things that you can do with a list, and you understand this performance issue that on an array list it matters where you're adding. Appending to the end is very fast. Inserting something at the front, not so fast at all. What else? I'll show you how to make a set. Now sets, so remember again, that's just an interface. The only useful implementation of sets that I know of that's in the collections framework is the hash set implementation. So we'll create a new hash set. And we can go iterating over S in L. We can say, name collision there. Set.add S. So now we create a new set, which we call set. And we add everything that's in the list to that set, and now we print out that set. What do you think is going to happen? Yeah. Yeah. Remember, sets are not ordered in any particular way. Let's put a marker so we know where one starts and one ends. So L had Stewart, Kripke, Howard, Amy, Leonard, Raj, Penny, Sheldon. Set has Leonard, Sheldon, Kripke, Howard, Stewart, Raj, Amy, Penny. Why that order? Yeah?
The order is the natural order of the hash of the,
Yeah. So let's say the external view of it is, it's the order that's convenient for the data structure to put it in to make it fast for searching. We don't have to understand why it's in that order. We just have to know that it's the order that it chooses. We can't rely on it. In some cases, and I don't think this happens in Java, but it certainly happens in other languages, you might run this program twice and actually see it come out in different orders each time. So don't rely on the order that things come out of a set. But we could, instead of using a set, we could use a sorted set. So let's do that. And one good implementation of a sorted set is a tree set. Now what order are they going to come out in? So they'll come out in sorted order, sorted by something. And they'll be sorted by the natural order on strings, which is lexicographic comparison, meaning that you compare two strings by looking at their two first letters, and which, if they differ, then the smaller one goes first. If they're the same, then you go to the second letters, and so on. If one finishes before the other one, then it goes first, and that's case sensitive. So I can, in my set, Amy, I can add Amy with a capital A, and that'll end up in there, and it comes out before Amy in this order. Capital letters before lowercase letters. Yep.
where's a good place to find implementations to use for all the things?
So on the web page for the course, you will find, if the internet is going to be nice to me today, so there's two links here. One is to the interfaces, and the other one is to the implementations. And here there's a nice table that shows for each interface pretty much what is the usual implementation you would use. Hash set, tree set, ArrayList, those kinds of things.
we have to zip each folder and each exercise alone, or we can zip them all together?
Just zip up the whole thing in the same format that you downloaded in.
Yeah, and we like number them 1, 2, 3, 4.
Yeah, so the skeleton that you download has all the files in the right place,
yeah.
so you just zip it exactly the same way.
Thank you.
So Stan said this is the partition you provided.
Yeah.
And maybe my knowledge is
Yeah.
so we don't need to, again, we do need to understand this part.
Well, so basically, you can use this. This shows you how to read everything from that input.
I still don't get it. It's not like array or...
So you don't have to touch main at all.
Okay. So I extruded the partition. So what kind of...
Yeah, it's waiting for input.
What kind of input, like number or...
Anything, a bunch of lines. Now the difficult thing here is you're inside an IDE, and I have no idea how you're going to tell it that you're done inputting things. Possibly Control D. There you go.
Control B.
Control D on the input line
with
seems to
Control
show.
B or Control D?
D.
So
D is in Daniel.
It executes...
So Control D signals that this is the end of the input. And it should stop reading it. Yep.
My question is, I'm not sure if it works because I was thinking, is it any faster if you, because you were talking about when it reverses, it's slower when it reverses.
Yep.
Is it faster if you start instead of at 0 for the for loop, you start by the end of the previous array that you're copying?
Oh yeah,
and then subtract by 1.
For sure. I mean that's an easy one. In fact, the assignment is also an easy one. But if you just iterated over the array in reverse order and add them to the list in that order, then that's fast. Yeah. So that requires you to do a little bit. I mean, you have to know. You'd say for I equals a dot length minus 1. I is bigger than or equal to 0, I minus minus, and now you're getting a at I. So you don't get to use that nice iteration where you just say for every string s in a do something, because that'll do it in the forward order. But if you can do the index calculation to iterate backwards, then that's another way to do it that would give it reversed in the way it works.
Okay.
Yeah. You know when midterm is?
October 21st. Friday, October 21st.
Okay.
When it comes to the headsets and tail sets,
Yep.
does that only work for sets that have numerical values?
No, it works for these guys too.
So, does it return like everything that's like greater than the value of 11, or like at the index 11?
No, everything greater than the value.
Okay.
So. So we have a sorted set, we can see what happens. For string S, yeah, sure. String S in set dot tail set of, let's say, everything that comes after pan.
Pan being like it'll take like the alphabetical, like all the
yeah, so you would look at Java. Yeah, so look at, here's the set, where would pan fit in this list, just before penny, and so you
so
get everything that
it's
comes after that.
alphabetically.
Yeah.
Okay, great. Thanks, Dane, by the way.
Nice to meet you.
Just wondering, do you post the code online?
Yes, I'll post this code online.
And you record the lectures too, I know, since the camera, right?
Yes.
Does it record like both the screen and the?
Yes,
Blackboard?
I